Hello everyone, this is Ziegler Studio. In this episode, we'll introduce AI. By the end of this episode, you'll understand how AI works and gain a clear understanding of patrolling NPCs. In the upcoming episodes, we'll delve deep into how to create AI, giving you a comprehensive overview so you can create the AI you desire. Stay tuned as we'll be covering AI detection and handling attacks. Keep watching. Shall we dive into the video? The first thing we need to do is set up the navigation area. We want the AI to move around, and for that, we'll use a nav mesh. To limit the volume, type nav in the left search bar, drag and drop it, and then toggle the boundaries to see where the NPC can move. The accessible areas are marked in green, while the inaccessible ones are in red. Since we need to create a few things first, right-click and create a new folder named AI. Next, we'll create an AI controller. Right-click, select Blueprint, then in the All Classes section, search for AI Controller, select it, and bring it into the scene. Rename it to NPC AI. Then, right-click again, go to Artificial Intelligence, and create a blackboard, naming it NPCBB. After that, right-click once more, go to Artificial Intelligence, and create a behavior tree, naming it NPCBT. So, what does all of this do? The AI controller, similar to a player controller, assigns specific properties to the NPC. The behavior tree essentially dictates what actions the NPC should perform and executes them accordingly. The blackboard, on the other hand, holds variables for the behavior tree. You can set variables in the blackboard, allowing you to change what the NPC needs to do at any given moment. To create an NPC, duplicate the third-person character and name it NPC. Then create a third-person animation graph and name it NPC Animation. Starting from Unreal Engine 5, you need to create the animation blueprint manually. Follow along with the video to create the animation graph exactly as shown. As for the event graph, I'll include a link in the video description below so you can copy and paste it. When casting to the third-person character, you need to modify this. Since everything is now linked to the NPC, cast to the NPC instead. Open the NPC BP, delete the camera, select the camera boom, then select the mesh and change the animation class to the newly created animation blueprint. Under Pawn, select the NPC itself. For the AI controller class, choose the AI controller you just created. Uncheck Use Controller Rotation Yaw, then under Rotation, select Character Movement as the rotation method. Enable Use Controller Desired Rotation and set the Z rotation speed to 200. Since the NPC is no longer controlled by the keyboard and mouse, you've provided an alternative way for it to rotate. Now you need to choose the appropriate rotation method. You can adjust both the rotation speed and these two options. If you're not satisfied with how the NPC rotates, experiment with different settings to find what works best. Let me introduce you to the behavior tree. Open it up and welcome to the behavior tree. At first it might look intimidating, but trust me when I say this, using it in Unreal is actually quite simple and fun. As mentioned earlier, the behavior tree is used to tell the NPC what to do by arranging tasks in a sequence, making execution straightforward. If you drag out from the root, you'll see that you have access to the Selector and Sequence nodes. I'll provide the official descriptions of these nodes here. These two nodes are quite similar. Use a sequence node when you want to execute multiple tasks in order. Use a selector node when you want to choose a specific sequence to run. Don't worry if this seems confusing at first. The more you use them, the more sense everything will make. Press the Blackboard button to create a new key as a vector, and we will call this the target location. Now let's create a location to store it. There are various ways to get values and locations, but the method I will teach you today is by using a spline. Right-click the Blueprint class actor and double-click this spline path to open it. Now add a spline component. You can now create a path for the NPC to follow. Hold the Alt key while dragging to create new spline points. Then, check the closed loop option in the Details section. Bring in a static mesh cube and set up collisions, ensuring there are no collisions in the Details section. Go to the event graph and create a timeline node. Double-click it to open, then add a float track. Hold Shift and click to add a point, setting the value to 0 at time 0. Hold Shift and click to add another point, setting the value to 0 as well. Then set the value at time 10. At the top, set the total time to 10. This represents the time it takes for the NPC to complete the loop. You may need to adjust this based on your program. Now go back to the event graph controls and drag in the cube. Set its world location and connect it to the timeline. The next node may seem obvious. It's essentially creating movement. Since it's moving around the spline, drag the spline in, get its length, and add a lerp node. Set A to 0, connect B to the spline length, and link alpha to the timeline. Duplicate the spline. Create a new node, then get the location along the spline based on distance. Set this to world location and connect the lerp to the set world location node. Finally, connect the position to the timeline output. Press D and click to create a delay node, then loop back to play from the start. This ensures that after the NPC completes one rotation, it waits for the delay before looping again. As time passes, the cube moves along the spline without actually needing to physically follow it. Since it's just a reference, we only need the position value. Therefore, get the position along the spline based on distance. Promote this to a variable and call it location. Great! Now we have the location and a place to store it. Let's return to the behavior tree in the Blackboard and get to work. Remember that we need one task to get the spline location reference and another to send the NPC to that location. Right-click to see the full list of tasks. Although many are already built into the program, we want to create our own task for this. Click New Task at the top and select BTT Task Base. This is just a default name for the new task, so we will rename it in the content browser. To get the spline location for every single task blueprint we create, we need an Event Receive Execute AI node, which is triggered when the task is called from the behavior tree, and a Finish Execute node to properly end the task. Make sure the success box is checked, or the task won't be transmitted. The way tasks work is by passing information between the NPC blueprint, AI controller, and the Blackboard. So you might wonder, how do we communicate with the spline? Or how do we get the location? Friends, since we're passing the location through the NPC, let's get started quickly. So, in the NPC blueprint, create a new variable and set the variable type to match the spline path blueprint. Name it spline path reference. Now check the instance editable option. Let's get a cast to NPC node using the controlled pawn as a reference. Since we created a spline path variable reference in the NPC, we can now cast to the NPC. With the spline path reference, we can access the location variable created in the spline path. Now, we just need to send this information to the Blackboard. To communicate with the Blackboard through variables, create a new variable and name it BBRef. Set the variable type to Blackboard Key Selector and check Instance Editable. Now we can retrieve and send variables from the Blackboard. Get the Blackboard variable, set the Blackboard value as a vector, and connect it to the position and this task. Now we successfully obtain the spline location through the MPC and send it to the Blackboard, updating the target location vector in the Blackboard. Duplicate the task and create a new one to send the location. Double-click it. Delete everything except the Blackboard reference and the 2 essential nodes. Now, retrieve the location we just set, get the Blackboard value as a vector, and add a simple Move to Location node, connecting the vector to the target. Next, move to the Owner Controller node, and the task will be completed. So, after retrieving the location, we send the MPC to that location through the AI controller. Now, return to the behavior tree and take both tasks to retrieve the spline location. On the left, both tasks will send the location to the right. In the Details section, make sure the BB is set to the target location. This means that when setting and retrieving values in the task, the target location variable will be set and fetched, so the behavior tree trigger actually executes in a manner similar to an event tick. After the task retrieves and sends the location, the MPC will move to that location. Since this is continuously sent, the spline location will be updated as the NPC moves, and the position will keep updating. Although we haven't done anything with the AI controller yet, the final step is as follows. To use it for sending the NPC to the location, you need to link it to the behavior tree. Go back to MPC AI, create a Run Behavior Tree node in the Begin Play event, and insert the behavior tree. Depending on how fast the spline moves, the mannequin's speed, or the size of the spline track, the mannequin might move too quickly or too slowly compared to the path. Therefore, you can set the appropriate value in the timeline. Now everything is complete. I hope you found this tutorial helpful. If you did, please don't forget to hit the subscribe button and give it a thumbs up. It really helps support Ziegler Studio and lets me know that you want to see more content like this. Thanks for watching.